Welcome back to Lift Right Academy. In today's video, we'll learn how to calculate outrigger loads and determine the correct crane mat size. Selecting the right mat is critical for safe lifting operations, preventing ground failure, and ensuring the crane remains stable throughout the lift. Let's walk through a full worked example step by step. For our example, here are the values we are working with. We have a mobile crane with a listed weight of 60 tons, which includes a standard 7-ton counterweight. However, the actual counterweight fitted for the lift is 15 tons. We also know the ultimate ground-bearing pressure of the soil is 80 tons per square meter. Our gross load is 8 tons, with rigging gear weighing 0.15 tons and a hook block weighing 1.32 tons. For this calculation, we will use a square mat. First, we determine the true crane weight with the actual counterweight installed. The crane weight, including 7 tons of counterweight, is listed as 60 tons. Since we are replacing the standard 7-ton counterweight with 15 tons, we subtract 7 and add 15. This gives us a total crane weight of 68 tons. Next, we calculate the static hook load. This is the sum of the gross load, the rigging gear, and the hook block. 8 plus 0.15 plus 1.32 equals 9.47 tons. This represents the suspended load at the hook during lifting. Now we estimate the load acting on the most heavily loaded outrigger. In lifting operations, a common method is to assume 75% of the combined crane weight and counterweight transfers through one outrigger when the boom is swung over it, plus the static hook load. So 0.75 multiplied by 68 plus 9.47 gives a total of 60.47 tons acting on that outrigger. To determine the mat size, we compare the applied outrigger load against the allowable ground-bearing pressure. First, we convert the ultimate ground-bearing pressure to an allowable value. Because we are using manual calculations, we apply a factor of safety of 2. 80 divided by 2 gives us an allowable ground-bearing pressure of 40 tons per square meter. We now calculate the minimum mat area required. This is simply the outrigger load divided by the allowable bearing pressure. So 60.47 divided by 40 equals 1.51 square meters. To get the mat side dimension for a square mat, we take the square root of the area. The square root of 1.51 gives approximately 1.23 meters. In practice, we don't select the theoretical value. We round up to the next convenient and commercially available size. Since our minimum side is 1.23 meters, a practical safe choice would be a mat measuring 1.3 by 1.3 meters, giving an area of 1.69 square meters. We then perform a check to confirm that the pressure is within limits. To check, we divide the outrigger load by the mat area. 60.47 divided by 1.69 gives 35.78 tons per square meter. This becomes our calculated outrigger pressure under the mat. Finally, we compare the outrigger pressure with the allowable ground pressure. 35.78 is less than 40 tons per square meter, which means the lift is safe using a 1.3 by 1.3 meter mat. And that's how we calculate outrigger loads and determine mat size for safe lifting operations. If you found this helpful, subscribe and stay tuned for more lifting, rigging, and crane safety lessons presented by Lift Right Academy.